Welcome back to next video based on thermal analysis, where we are going to learn the differential thermal analysis technique. Differential thermal analysis. In this particular technique, the changes we have done is we have taken sample and we have chosen one reference which withstand this high temperature and does not show any change. So we have taken over here as reference and sample. We have kept both of them in a furnace. We are applying temperature through thermocouple. Through furnace we are applying temperature. Through thermocouple we are going to check the changes in a sample. What we are going to do? Temperature between sample and reference. Difference in temperature has been recorded against time. Change in temperature as a function we are going to record over here in differential thermal analysis. So change in temperature versus time. This particular analysis gives me an information with respect to melting point of sample, its exothermic and endothermic phenomena. Downstairs peak, the thermogram obtained after DTA shows me some peaks as down, some peak as up. In TGA we have seen stepwise decrease in wet. Here we are seeing downstairs peak and upward peak. Downward peak indicates me endothermic change has been observed. Heat has been absorbed. Heat has been evolved in case of exothermic. So both sample and reference material must be heated under careful controlled conditions. If 0 is the temperature difference, that indicates me sample does not undergo any physical or chemical change. If any reaction takes place, the temperature difference will occur between sample and reference. If exothermic, upward peak, endothermic, downward peak. Differential temperature has been plotted against time. So the area under DTA peak is enthalpy change is does not affected by heat capacity of the sample. Enthalpy, one of the component you have learned during your thermogravimetric studies. DTA curve information we can gather largely endothermic and exothermic phenomena, heat absorbed by the sample or heat evolved. In case of endothermic, the phase change takes place are melting, vaporization, sublimation, and sometimes change with the crystal structure. In case of exothermic, the phase changes takes place, heat evolved, freezing, some transition between different crystal structures. With respect to the chemical reaction, in case of exothermic, we can see dehydration, decomposition, oxidation, and reduction. In case of exothermic, we may see same type of changes like decomposition, oxidation, reduction, chemisorption, not dehydration. The instrumentation part of DTA involves components like sample holder, thermocouple, recorder, output device. Sample holder, sample and reference compound, both are being kept in same type of crucible made up of aluminum or platinum or silica, which withstand the high temperature again over here. The best results are obtained when area of contact between sample, pan and crucible is maximized. Sample is generally 1 to 10 milligram chosen in case of analytical applications. Dimensions of these two crucibles where you are putting sample, these two crucibles, the dimensions should be seen with respect to cell well. I am not telling you cell wall, it is cell well, depth of the container and amount of the sample taken inside the container. Furnace, second component, where you have to take care that your furnace should be providing same environment for sample and reference, which are arranged symmetrically with furnace. Metal blocks surrounding the wells act as a heat sink towards your sample and reference. Temperature of the heat sink is slowly increased with using internal heater, and the sink in turn simultaneously heats or cools the sample and reference material. Furnace, here furnace, the operating temperature in case of DTA is up to 1600 degrees Celsius. Now there are being many changes done. If your sample needs the capacity to have higher the weight, manufacturer may provide your DTA instrument with 15 to 1500 to till 2400 degrees Celsius. Usually TGA DTA nowadays has been done in one instrument also. TGA DTA as one single instrument where you'll get both the data on one thermogram with decrease in steps and exothermic endothermic peak, which will be more useful. To reach very low subambient temperature, that is the room temperature or below room temperature, if you want to, you have to have an facility of liquid nitrogen which can attain the temperature below the room temperature. So some low temperature may affect the electrical cooling device or force. You can cool this furnace by electrical cooling or forced air cooling. If physical changes takes place in sample, usually heat is absorbed or generated. The sensors and recording system, very important part of your instrument. A pair of thermocouples used as a sensors in this case. One pair is attached to sample, another pair attached to reference. Output of this differential thermocouple, difference delta T, is amplified to the data and allow the difference to measure as a function of time. Where I can use this DTA apparatus, where I can apply these applications, which particular sample I can use, what is the information I can gather. Here you will come to know. You can find out kinetic study of your compounds to learn or to understand the order of reaction, to understand the phase diagram. You might have learned somewhere the phase diagram of water, how it changes, the state of the water, how it changes with respect to temperature. That phase diagram study of different materials you can do over here. Qualitative identification of materials can be possible over here. DTA of sample to DTA thermal curve of known materials. Like actually you are using an information of melting point of compound. For example, benzoic acid. This is known to you that benzoic acid has melting point 120 degrees Celsius. So if you are doing some study with respect to compounds, or you are measuring the melting point of some compound and it has shown me a temperature 120, you can correlate that information like that. DTA thermal curve serves over here fingerprint of materials. The standard data you can correlate it with the materials for known and unknown compounds. Characterization of engineering materials for their structural chemical changes. Heat treatment for alloys, you can study that. Identification and different types of synthetic rubber. Structural changes in the polymers, widely used in pharmaceutical and food industry. I'll take a pause over here, pharmaceutical food industry, that how I can use thermal analysis in case of pharmaceuticals. Now, when you take a simply tablet in your body, what your expectation was? It should remain as a solid? No, it should get dissolved. Now here, one parameter is pH, definitely pH of your body. Second is temperature. So disintegration, decomposition of your solids should obtain done at your body temperature. So this is simply the application you can apply in pharmaceutical food industry, where you want to have to maintain the taste of the product, color of the product at drying temperature. So you have to apply the drying temperature in such a way that you maintain the taste and all these color food facilities in case of food industry. In chemical, in cement industry too, in research and environmental studies. Now we'll look at some DTA thermograms. We'll try to interpret the data obtained in DTA thermograms. Till now we have understood that upward peak and downward peak is observed typically in DTA, which gives me the data of exothermic and endothermic reaction. Now we'll take simply over here an example of calcium oxalate monohydrate, where like there we have got step analysis at 100 or 110 degree loss of water. So here the peak, exothermic peak, endothermic peak, you can correlate with release of water. Exothermic peak you can correlate with release of CO2. Again, one more exothermic endothermic peak you can get over here. So what information you can gather from this data is enthalpy of reaction. Enthalpy of reaction you can find out simply the formula delta H equal to K into peak area. So K can be determined by measuring the enthalpy and peak area. Area under the peak you can find out. Interpretation of DTA of some of the polymers. Now here I have tried to show you one structure where polymeric structure is amorphous and another one is semi-crystalline. You can see over here crystallinity has been defined over here by straight lines, whereas amorphous structure is shown over here as waving. These are the two polymers if we have taken under study. For the first type of amorphous polymer, you can see the graph obtained shows only endothermic peak. It shows decomposition temperature with respect to endothermic peak, whereas semi-crystalline material shows crystallization temperature, exothermic peak as well as endothermic peak. This endothermic peak gives me decomposition, or I can say melting point, thermal crystallinity. Stability of the material, like we have seen in TGA, the stability temperature we come to know before decomposition, whatever temperature is there, we can see that as a stability temperature of particular compound. So this particular thermogram where your instrument is giving me TGA as well as DTA of a particular material simultaneously, the data has been obtained. This is one of the catalysts we have taken under study, where at 200 degrees Celsius we can say dehydration, first dehydration has been obtained. Again for this particular step, 400 to 500 degree particular deep step has been observed, where formation of oxide we can see for this particular material. The next example which we are going to learn or understand over here is how the phase transition in a compound takes place by using DTA instrument. Now we are taken here a sulfur as an example. You might have studied symmetry. There are different structures, symmetrical elements of the sulfur, that is rhombohedral monoclinic structure of a compound. Now when I got the DTA of this particular sulfur, I can see over here that all of the peak are having upward direction. What it indicates you? All reactions are taking place endothermic. Now what we can see at 113 degrees Celsius is happening to this sulfur compound. At 113 degrees Celsius, it tries to change its structure from rhombohydrate to monoclinic. At 124, you can say the melting point of your compound. At 179, it changes into liquid phase, transition, and your solid has been transited completely into liquid phase, and at 446 degrees Celsius, it started boiling. So you find out, you have gathered the information, you can find out the data, endothermic reaction, exothermic reaction, enthalpy of a compound, and melting point, boiling point, along with phase transition. So you can find out melting point of compound. Simple example I try to show over here, that is the benzoic acid. White color solid organic compound during organic qualitative analysis also you might have utilized. Can anyone tell me the melting point of this compound? Yes, correct, 120 degrees Celsius. So you can see this endothermic peak. You can see here the melting point of compound takes place in case of benzoic acid. We'll just have a look over the two instruments which we have learned or understood in my last two videos. First, thermal analysis video, we have learned the thermogravimetric analysis, and in this video we are learning the differential thermal analysis. We'll just try to understand what is the difference between these two techniques and what information we can gather. Can you tell me what we have learned in TGA? Yes, weight loss as a function of temperature. Can anyone tell me about DTA? Difference in temperature of sample and reference as a function of temperature. The data curves What are the typical attackers? If you close your eyes, what are the typical attackers in case of TGA? Yes, stepwise analysis. In case of TTA, upward and downward peak. The instrument which you can use in TGA is thermobalance. In DTA, simply DTA apparatus. Information you can gather in case of TGA is change in mass on heating and cooling. In case of DTA, heat absorbed or evolved. The operating temperature differs over here up to 1000 or 16,000 degrees Celsius. Here you can go above 16,000 degrees Celsius also, depending upon the manufacturer which you can choose. The analysis we can do over here is in case of TGA with respect to loss in mass. Here quantitative analysis we can do by measuring the peak areas and height. We can apply TGA on large scale for finding out purity, composition, drying, ignition and stability temperature. Here we can get the data. Can you tell me? Yes, melting point, boiling point, transition temperature, specific heat of reaction, very good, and stability temperature. Yes, thank you. Hope you have enjoyed this particular video and you have understand both the thermal analysis technique. I'm awaiting for your subscription. Hope you have enjoyed this today's video based on thermogravimetric analysis, where we have learned all the components of the instruments, their thermograms, their applications. I just like to devote this my today's video based on thermogravimetric analysis and the upcoming video of differential thermal analysis to my guide Dr. Jyoti Salvekar, who was former head and principal of SP College. She has major contribution to this thermal analysis. She has taken an initiative to construct both the instruments which are still working in our department. Thank you.